from the Canadian Institute of Energy Training, representing the Save on Energy program. Our presenters for most of the session today are the team from BPA, and they have conducted, I think it's fair to say, hundreds of EBCx projects in buildings across Canada. So I think most folks are here. Let's go ahead and get started. For those of you who have already participated in some of our events, sorry, I'm going to go ahead and mute everybody again. For those of you who have participated in some of our events in the second half of last year, today's event is going to be a bit of a deeper dive into the investigation phase of EBCx projects. And in fact, this is just part one of what is really a two-part training session. There's a lot of content. We're going to get into more detail about functional testing and a lot of the kind of the nuts and bolts of the investigation phase. So we're going to be 90 minutes today, and then there's going to be a second event next week that I hope you all will participate in as well, where we will get further in. So today's agenda, first, I've got some really quick program updates about what's available from Save on Energy. And then, as I said, we'll turn it over to the BPA team. First, we're going to get into kind of the planning phase, because depending on how you think about EBCx, planning and investigation can be together, but we're pulling them apart here today to treat them both in detail. And then we will get into the investigation phase itself and talk about some diagnostic monitoring. But because we're limited to 90 minutes today, it's that session coming up next week on January 18th, where we'll really dive into more detail about functional testing, documentation, savings estimation, and providing that investigation report. So I hope all of you will be able to attend that event, and I'll make sure and share the link for that in case you haven't already signed up. I will include that link in the chat. I'll also say, before we really get started, we will have time for Q&A at the end. Please do, if you have questions as we're going, please do share them in the chat, and then we'll have them and can moderate that discussion when we get to the end. So feel free and use the chat to share your questions as we go. We'll come back to them when we get to the Q&A at the end. So really quickly, to talk about some of the resources that are available right now from Save on Energy. Yes, Graham, to that question, these sessions are being recorded, and you'll have access to all of those recordings. And in fact, the recordings from all of these EBCx events, those that we did last year, this week, next week, are available on the Save on Energy training and support website. I'll put that link up in the chat in just a moment. So all of you will have access to those recordings. We've also got there a practical guide. It's about a 5 or 6 page guide specifically for building owners about how to navigate the EBCx process. Some shorter information sheets about, I think a lot of it has to do with really what is EBCx and how to know if your building might be a good candidate for an EBCx project for different types of buildings. We've got 5 or 6 of those. And then information about training incentives for different types of EBCx courses, courses that would be appropriate for building owners and managers, or folks who are getting into executing EBCx projects. Then just a really quick overview. Save on Energy also offers, I think you all are aware, the EBCx incentive program, which works in 3 phases: investigation, implementation phase, and persistence phase. And today and next week are all about that deeper dive into the investigation phase. There was a question just a moment ago about whether continuing education credits are available for attending these webinars. I'm sorry, they are not. We don't offer continuing education credits for those folks. Okay, at this point, I am going to turn it over to Megan and Aurélie and Eddie from BPA, who are going to lead us into the investigation phase. Take it away.
Okay, so the investigation phase. As Jess was explaining, is the first stage. It allows the EBCx team to analyze the system operations in detail for the building, carry out diagnostic tests, propose measures to optimize the operations. And then these measures are presented in a findings logs, which is part of the investigation report presented at the end of the process. The investigation phase has 3 steps: the planning and pre-screening step, the planning and initial assessment, and investigation and report step. We are going to be reviewing the first 2 in this presentation, and then part 2 looks further at the third. So the first part is the planning and pre-screening, and it includes selecting an appropriate building, defining the EBCx objectives, defining the current facility requirements, and defining the scope and roles and responsibilities of the people involved in the process. So when you're looking at selecting a building, what kind of criteria should you consider? How do you decide what the best building for EBCx is? So some of the things you should look at is the engagement and the available budget from the owner, the engagement from the building staff, what building documentation is available, is there a building automation system or a BAS? And if there is it still maintained and it's not obsolete? The BAS documentation that's available and what the capacities of the BAS is able to do, such as trending. The budget for implementation and handoff. Is it possible to have a realistic schedule? A minimum of 3 seasons is recommended. What's the energy use intensity, the EUI, of the building? So what's the energy efficiency potential for the building? Are the building systems and equipment in good condition? So there's no extensive repairs needed to your equipment. And what's the equipment and building systems useful life? Are they scheduled to be replaced in the near future? And then you also want to look at any incentive programs that are available to help offset the cost of the EBCx process. So to help you select a building, NRCan has developed a pre-screening tool. They have done a, they've developed a pre-screening tool to help identify the most appropriate buildings, and they've done a survey of a large number of buildings to evaluate the improvement potential and readiness for an eventual project. If you have a large portfolio of buildings, this will help you prioritize what buildings have the greatest likelihood of success and help you to capitalize on short-term paybacks and support long-term planning. And this pre-screening tool is intended to be used at the planning phase of the EBCx process. One thing we've referred to in an earlier slide was the energy use intensity. And energy use intensity is expressed as the energy per square foot per year. It's calculated by dividing the total energy consumed by the building in 1 year by the total gross floor area of the building. And it's a key metric to benchmark a building. Essentially, it expresses the building's energy use as a function of its size and its characteristics. And a low EUI usually signifies a good energy performance. However, depending on the type of building, you might see some buildings have a higher EUI. For instance, a hospital would have a higher EUI than, say, an elementary school. So things that affect the EUI, as I said, was the building use type, the climate, the building age, building size, occupancy, the types of mechanical and electrical systems and their efficiency, and the operational efficiency. So here's two types of buildings to help you choose that we'll look at to see if they're good candidates for EBCx. Which one of these would be the better candidate? So building A is a large office building. It was constructed in 1980. It has an EUI of 1.5. Has a central boiler plant, a central chiller plant, but there's no documentation available on the systems for the building. The BAS system is old and it's not maintained anymore. Building B is a medium school building. It's constructed in 2010. It has an EUI of 1.1, and it uses innovative and complex mechanical systems and sequences. For instance, it's got a geothermal system and it has heat recovery. It has all of the design and construction documentation available. The BAS is newer and remote access is available. So when you compare the two buildings, some of the positive points for building A is that the EUI is relatively high, meaning that there's more potential for energy improvements. But the negative points is that there's no documentation available. So the EBCx consultant will have to spend more time collecting the information and maybe create new documentation. And the larger negative point is that there's no BAS. And typically, EBCx measures are related to the controls for the building. So this could make this a possible no-go. Building B is a relatively recent construction, generally meaning it's not the best candidate, but considering the type of complex systems, the EUI is on the higher end at 1.1. So there is a possibility to improve the energy efficiency. Complex systems are also less understood by operating staff, so they may not be, the systems might not be run to their full potential. So there's a potential improvement in that area. So looking at the benchmarking and the EUI, in the previous slide, I referred to some of the EUIs being on the high side. So how do you know this? The next few slides, we'll look at resources to help you determine if your building has a high EUI. NRCan's done a survey of commercial and institutional buildings. And the purpose of this survey was to collect statistical information on the energy demand and consumption of different buildings and to compare them based on the types and quantity of energy used, such as electricity or natural gas, and the building characteristics to better understand energy consumption for a typical building. This table presented shows average EUIs, and if you refer to the building, the slide that we had before, our office had an EUI of 1.5, building A, but you can see from this table that an average office space would have an EUI of 1.05. Similarly, for the elementary school, it had an EUI of 1.1, but an elementary school would typically have an EUI of 0.91, showing you that there's some energy potential there. We also have hospital buildings pointed out, and you can see that they have, the average hospital has a much higher EUI. So that's when we were talking about before that depending on the building type, you might see a very high EUI. It doesn't mean that that building, it has a high energy consumption, because when you compare it to a building of similar types, they have higher EUIs. Another tool that can be used when looking at EUI is the BOMA report. So BOMA Canada collects the data for BOMA Best certified buildings across Canada. It's not as large a group of buildings as the NRCan survey, but it's still a useful tool. And as an example, a BOMA Best certified building in Ontario has an average EUI of 0.9 about. And the last tool that we've looked at is the Energy Star Portfolio Manager. So this is a web-based benchmarking tool, and it allows you to benchmark the energy performance for all of your buildings. And it's a valuable management tool because it's used to compare and manage and track energy usage over time. So you can see if there's any decreases in energy efficiency. It also calculates valuable metrics that can help you identify underperforming buildings, and it helps you set investment priorities. The Energy Star score, it goes from 1 to 100, and it compares your building's energy performance to similar buildings nationwide, and normalizes for weather and operating characteristics. A score of 50 represents a median average. So if you're above 50, you're above average. And if you're below 50, you're below average and underperforming. So another one thing we want to look at a part of the planning process is the EBCx objectives. You're going to want to try to focus on 1 or 2 primary objectives. Some of the objectives you'll want to review would be resolving O&M issues, enhance energy efficiency or reduce your environmental footprint, reduce operation and energy costs, that would be the EUI, and improve comfort indoor environmental quality, improve systems performance and your controls, improve O&M staff training and building documentation, identify possible capital projects for further investigation. Another thing that needs to be done as part of the planning process is to identify the current facility requirements, CFR. This table is an example of what can be filled out by the owner to identify their requirements for each space type. You would want to identify the space conditions for each space use, so the temperature and humidity requirements, the operating hours and occupancy, any special air filtration requirements, the amount of ventilation or outside air. This helps us determine what's possible as part of the EBCx process, remembering that the objective of any recommissioning project is to ensure that the building is operating to the owner's requirements. So the project scope for the EBCx, you'll want to look at your chiller plant and heating plant, the domestic water systems, ventilation systems and exhaust systems, variable air volume or VAV boxes, your perimeter heating systems, lighting controls, other mechanical systems such as heat pumps or circulating pumps, the BAS systems, including things like sequence of operations, set points, schedules, etc. We don't usually look at plumbing systems like the non-energy plumbing systems, fire protection, elevators, sanitary pumps, chemical treatment, water treatment, systems like that. When looking at the project scope, you want to consider these following items to determine if your building's good, or determine what can be done. So you want to look at the equipment and system complexity, building size, future renovations if they're going to be done in specific areas, any systems that are at the end of their useful life, any known O&M issues, and if there's a limited budget and schedule. So if you have problems with these issues, it doesn't mean the EBCx needs to be canceled, but you may want to adjust your project scope. So you might want to start focusing on certain areas or spaces. For instance, you might want to just focus on the chiller plant. You might want to look at major systems such as the major ventilation systems, or use a sampling method for repetitive systems like VAV boxes that may be very similar throughout the building. Or you might want to exclude some areas or systems. If you know there's going to be an area that is going to be renovated in the near future, you may not want to look at that, or if there's replacements for major pieces of equipment.
Thanks, Megan. So we'll pursue the planning phase with roles and responsibilities for EBCx project. Here you have a table summarizing the task for a commissioning provider and the owner. We'll start with the commissioning provider. He is the lead for the EBCx process. Commissioning provider will identify measures and perform tests. He will also coordinate the commissioning team, and he brings in internal and third-party team members at the right time during the project. On the other side, the owners team is composed of property or facility manager and the operation and maintenance staff. And the owners team is engaged from the beginning of the project. The owner will determine availability of internal resources, and also, of course, it will hire the commissioning provider at the first step of the project. It will contribute and review to the CFR during the initial assessment phase. It will review and approve the EBCx plan and scope. And at the end of the investigation phase, the commissioning provider and the owners team will review together measures, and the owner will approve measures to implement for the next phase. Then, during the implementation and handoff, commissioning provider is still the lead. So if additional investigation is needed, or maybe more engineering calculation is needed, he's gonna look at that. He will engage subcontractors for the implementation of measures and maybe adjust savings. During the handoff, it will be supporting the staff for training, so maybe develop a training plan and also update documentation for the project. The owners will support the training, and at the end of the project, maybe an ongoing commissioning plan will be developed to follow up on results. The facility staff has a great impact on the success of EBCx project. So you want to involve them really earlier during the process, so they can assist actively in the EBCx process, for example, to gather existing documentation, maybe prepare a list of known problems or opportunities, calibrate sensors and actuators, ideally prior to investigation. If maintenance is needed, they can perform it before the investigation begins. O&M staff will also help commissioning provider to understand the building and their systems, collaborate to perform functional testings, and maybe during investigation and implementation to perform simple repairs or improvements discovered during the investigation. Now, another third parties that could be involved in the project is contractor or manufacturer representatives. They can be involved during investigation and or during implementation. First, we can talk about the controls contractor. Controls contractor could be involved during investigation, for example, for sensor calibration, controls measures. They can also update sequence. They can also review programming code, or maybe communicate with the commissioning provider to give the actual sequences of control. During implementation, controls contractor can help to maybe update sequences for one or several measures and gives recommendations on measure implementation. a support from a testing and balancing specialist could be needed here. For example, if you want to test or implement a measure on a ventilation system. Finally, service contractor will assist in the same manner as a control contractors, but for larger equipment such as chillers or boilers. So we went through the pre-screening planning phase. Now we'll go through the initial assessment activities. The objective of this step during the EBCx project is really to have a preliminary understanding of the building, of how and why building systems and equipment are currently operated and maintained. You also want to understand areas of performance concerns and maybe determine how much potential there might be for improvements. It will also help you to focus later during investigation phase according to the result of your initial assessment. The activities here are first to review building documentation, develop an initial EBCx plan, analyze energy data, then conduct a kickoff meeting. So kickoff meeting, during the kickoff meeting, a commissioning provider will present the initial EBCx plan and will mostly discuss the work schedule with the owner. Then an initial walkthrough will be performed with staff interviews, and the EBCx plan can be updated according to those results and to issues and opportunities observed during the walkthrough. So starting with building documentation, the commissioning provider will review existing building documentation for a better understanding of the building and maybe note what documentation is missing. The facility staff or the owner should gather existing documentation prior to the site visit. So what should be, what are you going to expect here for documentation? We can talk about original design documentation, equipment list, nameplates, shop drawings for larger equipment, chillers, boiler, air handling units or pumps, control drawings, mechanical drawings, and also all about the building automation system and controls equipment, such as controls diagrams and sequences of operation. If they are available, testing and balancing reports are very interesting for the investigation. And if they exist, maybe you'll have access to previous energy studies. So we talked about the EBCx plan here. An EBCx plan, you want to document goals, roles, and responsibilities. You want to document the EBCx process, maybe describe major activities and tasks, and you want to show the overall project schedule. Here we present an example of a table of contents from that document. So first, you want a quick building and systems description, a scope of work, so which systems will be covered by an EBCx investigation, a preliminary energy analysis, the investigation methodology, who is the EBCx team, like I said, a work schedule, deliverables that the owner will expect, and documentation review. What do you have in your hands? What the commissioning provider have in their hands, and what is missing? Also, you can add current facility requirements and maybe a diagnostic monitoring plan. This document is really like work in progress during the whole project. So it's a working document, and it will evolve during the process. Here we present some examples. In that slide, you can see a quick description here at left for systems. So in that section of the plan, you want to have a quick description of buildings and maybe talk about the occupancy type, occupancy schedules. You can add a summary chart for large equipments. Here you can see hot boilers and chillers in tables. At the right, you have a preliminary energy analysis. Here we show a 3-year historical consumption for all energy sources. Here you can see the natural gas consumption, but you want also electricity. In that energy analysis, you also can add benchmarking analysis and maybe talk a little bit about the energy potential of the building as a preliminary guess of what could be done with the EBCx project. Then you want to show in the EBCx plan roles and responsibilities, as we talked about, and the scope of work. So in the scope of work, you should describe what is included and excluded from the project, from investigation, and if sampling methods are used, for example, for room controls, maybe it should be explained here. So in this example, 15% of the controlled spaces will be tested. It will be written here in the plan. And the last example is for a diagnostic monitoring plan. Here we will talk about it later in the presentation for the monitoring, but you maybe want to add it in the plan because O&M staff can start to set up some trend logs earlier in the project. So it will be all available when the investigation will start. Here we present an example of a work schedule. In this example, planning also include activities like financial incentives application and building automation system remote access. So that kind of activities can be done really early, have to be done early in the process and in the planning phase. For investigation, here it will cover, in this example, 3 seasons, winter, spring, and summer. As you can see, the boiler plant investigation is planned during winter, of course. The chiller plant is planned to be done during mid-season and summer. And the air handling unit ventilation will be covered over 3 seasons to see all operating modes. So in heating mode, cooling, and in free cooling if applicable. In the planning phase, you also, the commissioning provider will have a preliminary energy analysis to present and to address. Ideally, you'll have a 3-year historical consumption for the energy sources. So with that data, you can see and address the question: is there a rising trend over the recent years? And if yes, maybe it can be explained by the O&M staff or the owner. So the commissioning provider will see if there is a climate conditions differences between the years. Maybe ask to the owner if the occupancy rates have changed in the recent years. So for example, here, if building was partially empty during the year 1, then it means that energy consumption should be lower for that year. Maybe renovation or expansion have occurred. And lastly, maybe there is a change in space use or operating hours that can explain differences. For example, a tenant who occupied like 50% of the building has no employees working 7 days a week. So that means for operation that ventilation systems now operate 7 days a week, and energy consumption here should be higher now than the last few years. Then for energy data, the commissioning provider would choose a baseline year, which will be helpful for future energy savings calculation. A baseline year is chosen. It must be the most recent year, but it has to be representative of the actual building occupancy and operation. You also want to perform an energy inventory. So you want to calculate energy consumption for heating, cooling, fans, lighting, and etc. And finally, you want to analyze demand data and peak demand. Initial walkthrough. This is during the planning phase, so it's the first site walkthrough for the commissioning provider. The commissioning provider and the facility staff will conduct that walkthrough of all major spaces in the building to have a better understanding of the building occupation and operation. The tenant's floor, a walkthrough of tenant's floor is here to understand occupancy levels, maybe conditions of interior spaces, lighting and room controls, for example. Then a walkthrough of all major mechanical rooms, example, central plant, major air handling units. The commissioning provider will also have to address the general condition of equipment, spend a lot of time for a building automation system review, graphics, trending capacity, sequences of operation. And then maybe address or detect if calibration and maintenance is required prior to investigation. So now I present here a template of a facility staff interview. In that interview, you want to document known operational issues and improvement opportunities. So it can be done during the initial walkthrough, and it will address questions like if there are any changes in space use, occupied hours in the last few years, concerning mechanical equipment condition. If there, I don't know, maybe repairs required, capacity issues from boilers, from chillers, if there repairs required for pipes, ductwork, valves, etc. Concerning the control, mechanical control, the building automation systems is adequate for control and monitoring. The terminal system control is satisfactory, space temperature control. So O&M staff have the experience of the building, and they can raise problems and O&M issues to the commissioning provider here. You also want to address the lighting control and if replacement or renovations are planned in the short or midterm. Then here we present a template for building occupant interview. So it's not always done in an EBCx project. You should consider involve occupants when there are thermal comfort issues, and if that thing is one of the objectives of the project. So in that interview, you want to address if there is spaces changed, if the spaces have changed of purpose during the last few years, if there is thermal comfort. So you can ask areas and times of the day where space temperature controls do not work well. For indoor air quality, maybe some areas where the air quality is poor. And for lighting, if increased control are needed here. So this slide end with the planning phase, and I let Eddie to continue the presentation.
Perfect. Thank you, Aurélie. If you don't mind, I'll take control of the screen. My notes are in the PowerPoint, so just a second, everyone. Do you see my screen?
Yes.
Yes.
Okay, here we go. Thank you. So, pre-screening and we've already seen the pre-screening and initial assessment activity. They confirmed that the building is a good candidate for a recommissioning project or existing building commissioning project. They allows you also to gather the required information, assign roles and responsibility, and start, of course, the project. Then comes the third part of the investigation phase, the technical activities, which are really the heart of a recommissioning project. That is to say, the activities which will allow us to discover opportunities for improvement, to evaluate the potential for improvement, and obviously to document everything in a report. So basically, investigation activities will typically include the establishment of trend curves and all diagnostic monitoring activities, which will allow you to collect precise data on the specific functioning of the system. We will also continue to analyze the documentation to understand what was the design intent of the original designers, and also the limitation of the systems, validate whether the control sequences and ways of operating are logical and consistent with the capabilities of the systems. Also, one of the main activities is carrying out, of course, functional tests, which make it possible to concretely validate whether the system work and perform as expected. All these activities will normally lead you to discover opportunities for improvement, which will be described in a finding log, a document which will essentially include the description of the deficiencies observed, the means proposed to improve the situation, the anticipated savings, and the cost of implementation. There is obviously the production of an investigation report, which in addition to the finding log will add information and recommendation to proceed with the implementation of measures and answer such questions as who is going to implement the measures and how, the schedule of the proposed project, and so on. Ultimately, these documents are presented to the owner or building manager, explain, and the client will choose the measures they want to implement in their building. In today's training session, we will only cover the topic of diagnostic monitoring, and we will cover the other points in the next week webinar. As mentioned, the additional analysis of the documentation will essentially aim to understand the characteristics of the building system, HVAC, electrical system, and so on, that are part of the commissioning, and to understand different information, such as what was the design intent for a specific system, what was the original sequence of operation, what is the expected performance, etc. Obviously, the goal of an existing building commissioning project is not necessarily to reestablish the initial sequence of operations, since the building evolves over time. The goal is, in fact, to improve the existing situation as best as possible. But to do that, you need to understand, and you need to have a good grasp of what the system can really deliver, what are the capabilities, what is the expected efficiency, and so on. An example of that, the observation that a part of the building was initially designed with a high occupancy rate, for example, which obviously implies a high emission of outside air and cooling capacity according to the occupancy. A few years later, 5 years, 10 years later, it's possible that the condition of occupancy have changed drastically. A good example of that is following the COVID-19 pandemic, several buildings have significantly changed their occupancy density. So it's always a question of the sequence of operation and the outside air intake been adapted to the new condition, for example. So it's by analyzing the documentation and comparing to the occupancy condition that we will be able to determine this. So this is just an example of what the analysis of the documentation and the comparison with the actual operating condition of the building will make it possible to detect as an improvement measure. Another common activity is carrying out a visit outside normal operating hours, which is here what we call the night walk. This activity will often make it possible within a few hours to detect ventilation system, pumps, exhaust fans, or lighting system, which remain in operation for no reason and often cause unnecessary energy consumption. It's a very simple activity to carry out, but often pays off in existing building commissioning. Another example of a possible outcome of the night walk is the determination that the night setback temperature is not functional. It's another possibility that could be discovered by doing that. The next activity, diagnostic monitoring, will be the subject of the next slides of this presentation, and the subject of functional test will be covered extensively, I would say, during the next webinar next week. Diagnostic monitoring. Diagnostic monitoring involves in fact, collecting detailed operating data on the different system in a building. For example, collecting data on the position of the economizer damper during a day, data on the mixing temperature in the air handling unit, data on the humidity and temperature in the supply and return of a system, and so on. There's as many examples as there are kind or type of building and system. Obviously, by observing the systems operating with the building control system, it's possible to see this information from time to time. But when we collect the data over a long period of time, we will see trends or problems appear that are difficult to see instantly at a glance when you're in front of the operating station. Important point, you must be careful when implementing trend curves, and each control system is different depending on the manufacturer and the age of the system. For some system, it's easier than other to implement data logging. Some system have recording capacity limits that must be taken into account. And these limits well, they can, if they are exceeded, they can even affect the proper operation of the system. This is less and less common, I would say, than 10 or 15 years ago, because systems are, I would say, have greater capacity than what was in place maybe during the start of the millennia. But it remains an element to validate with the manufacturer or the building operator if he knows his system well enough. Having remote access to the BES system is always also an asset that will facilitate many existing building commissioning tasks. And basically, we are always trying to obtain this access. But depending on the client and the sector, I would say this is not always possible or easy. There are certain fear that the system might be used in a bad way or a breach of access, and also limits depending on the type of building. For example, a building in the national defense sector, you can try to have the remote access, but generally it's very hard to obtain. When the control system has limits or measurement is needed for an element that is not controlled by the BAS, it may be necessary to use portable recording equipment, which still happen quite frequently, depending on what you want to measure. In certain cases, it's also necessary to hire a contractor to carry out some kind of measurement. And an example of that would be efficiency of boiler, so combustion test. Another example, and it's always depending on what kind of equipment you have at your office or in your team, it might be necessary to hire a balancing contractor to measure airflow, water flow in some case. So that's the type of measurement that usually it's not always easy to do by yourself. For all these elements, preparing a diagnostic monitoring plan is essential to clearly establish what we want to measure and record, by what means and for what objective. Accumulating data without a specific purpose will only increase the workload, not in a useful way. So we must clearly determine what the objective of monitoring is. In the next few slides, we'll see what is a diagnostic monitoring plan. Typically, diagnostic monitoring will generally aim to collect precise and detailed data on the following elements. So first of all, of course, energy consumption. When you already have energy meter, existing meter and sub-meter, often building manager already have monthly data for these meters, but what often interests us in existing building commissioning is to have a more, I would say, granular data, for example, every hour or every 15 minutes, which make it possible to detect anomalies impossible to see with monthly data, or very difficult to detect. Other elements which are very generally included in monitoring would be water and air temperature, water or air flow rate when available. It's not always the case. Static pressure, set points which change according to programming, controls such as on-off on pumps, fans, and so on. Valves and dampers, modulation, motor amperage, etc. So there's a lot of information that can be obtained by the BAS system. Obviously added to this are the temperature and humidity condition outside the building as well as in the room. Of course, outside of the building, it's always useful when you're going to do the analysis afterward. You need to understand what's going on outside the building. Is it normal that my building is trying, or my system is trying to go into heating mode, cooling mode, or free cooling, and so on? So to understand that, you need to have the outside air temperature and humidity. So regardless of the format, the diagnostic monitoring plan will generally always include basically the same information and will help guide the commissioning team to implement the required measurement. Who will implement the metering really depends on the client's internal capabilities, the capabilities also of the building management system, and the desired objectives. The first element, there is obviously the objective or what we want to check on the mechanical or electrical system. For example, the objective could be to validate the percentage of outside air admitted into an air handling system by measuring mixing and outside air temperature in the air handling unit. Another example, we might want to check if we suspect a problem of poor adjustment of the PID parameters on heating or cooling valves, or we could also only simply want to validate if the operating schedule of a system is respected. There's really a whole variety of information that we may want to validate in existing building commissioning. Of course, a crucial element is determining which measurement points need to be tracked. Even more important, I would say, we must define the duration of recording and the frequency which will we do it. This element is important because depending on the objective, the measurement frequency will also vary. For example, if the objective is simply to validate an operating schedule, a recording frequency every 30 minutes or 15 minutes might be more than sufficient for this objective. On the other way, if the objective is to validate whether there's a cycling problem, more commonly known as hunting, the recording frequency may have to be every 30 seconds. To be able to see it. So it's the same principle with the recording duration, which will vary depending on the objective. When using portable data loggers, we will also have to add the characteristic of this measuring equipment, which will be who will be responsible for the installation and recovery of the data. Where the portable data logger must be installed, the date of start and end of measurement, etc. Obviously, if we want to record, if we want the recorded data to be meaningful, we must ensure that the measuring equipment is, I would say, reasonably calibrated. And it's true also for the BAS system sensors. If you're trying to do an analysis of your monitoring with insufficiently calibrated BAS sensor, well, you will probably don't reach the correct conclusion in your analysis. So here is the first very simple example of a diagnostic monitoring plan. In this case, we want to validate how an air handling unit operates. More precisely, how it modulates its temperature, validate if the temperature reset sequence is functional, and if the heating valve operates correctly. So here's an example of the list of points that we could follow. So you see that the discharge air temperature, the set point, the mixing air temperature in the air handling unit, discharge air temperature or the supply air temperature of the unit, heating valve modulation, fan status. So this is an example only. Maybe I might add an information here. When you see in the last column, you can see that in most cases we would probably propose a 5-minute interval for this monitoring plan. And the last one, we set that to change of value. It's oftentimes an option that is proposed in the BAS system for trending data, which mean in that case that we will save data only there when there is a change. So this is particularly useful for on-off points such as fans and pumps and so on. Here's another example that a little more that is I would say a little more formal, but with essentially the same information. In this case, we want to validate the operation of a system comprising 2 boilers and a hot water heating system. So in this case, we want to measure the outside temperature, the return and supply network temperature, the outlet temperature of both boiler, operating status, and we could have added modulation of the burner. I think it's
Mejor
something.
ya. Un tecito.
Sorry,
Muchísimo mejor.
there's a mic that stayed open, I guess.
Yeah, sorry, I will mute everybody.
Okay, let me go back to the presentation. So in this case, well, we already saw the list of points. You can see that we want to record data for at least at a week at 15 minutes interval. And in that case, the objective would have been to validate network temperature modulation versus outdoor temperature. So we want to check if the outdoor reset is still valid. We want also to validate operating stability of the 2 boilers and see if they are not short cycling, which, as you might know, strongly impact boiler efficiency. Just a quick example of why we want to we want to adjust the measurement frequency depending on the objective. So the first graph at the top of this slide, we want to verify indoor the indoor temperature conditions. Usually for such a measurements, 15-minute sampling is more than enough. And the second one is to validate or verify heating valve modulation and PID control loop. And in that case, of course, the frequency of measurement need to be much more rapid, I would say. And if you were to try to do this analysis with a 15 minutes interval, you would probably miss short cycling. And this is why determining the correct frequency of measurement is important depending on the objective. Very quick information about portable data loggers. There's a variety of them. I would say some, and I would say in that slide, most of them are more instantaneous measurement. So you could want to use a lux meter to measure lighting levels, pressure meter to verify if a air handling unit pressure sensor is calibrated. That's just an example. Digital thermometer will be used to verify temperature at different points on heating network or cooling network. Infrared gun, infrared camera can be useful also. Indoor air quality meter can allow you to see if there's indoor air quality problems in some area, or I would say the opposite. If everywhere in your building you have very low CO2 levels, might be an indication that the air intake is more than sufficient or too much outside air intake. So it might piss you very show you that there's a problem with the outside air intake. Also, you can see that the third one on the first row isn't. I don't want to do publicity, but you might know the company Onset, who is doing a lot of different type of portable data loggers. So these are more for example, for a week of measurements. You have sensors. You can use these data loggers and leave them either on a system for a week, for a few days, and register different type of measurements such as temperature, humidity, pressure, and so on. So there's basically no limit of the type of measurement you might be able to do with those type of data loggers. And finally, you might need to have other measurement that will be usually done by a third party, or in some case, the building manager or building operating team also have these type of measurements, but I would say it's not that often that you will see those conditions. So you might want to do electrical measurements with a certified electrician, liquid flow using ultrasonic flow meter, airflow or water flow measurement with a balancing contractor, combustion efficiency testing for boilers, and so on. So usually engineers don't always have these measuring equipment. So in those cases, if needed for the existing building commissioning project, you might want to retain the services of a third-party contractor to do some measurement. I guess it brings us to the question period. Jess?
Great. Thank you, Eddie, Aurélie, and Megan. We've got about 20 minutes left. There were a number of questions submitted as we went, but I think most of them got a response of one kind or another. So maybe I'll just ask, if you did submit a question and someone did respond to it, but you want to follow up or get a little bit more precision, or ask the BPA team for their expertise on it, feel free to open your mic and ask away.
Oh, I was just gonna add a little tip that I have when I do trends also for some clients. Always a good idea to keep the interval to the same time period. So when you do an export of these trends to Excel spreadsheet or something like that, they're all going to be aligned. Otherwise, you might find it messy. And I would say further, if some of the clients have trends already created that are at different time intervals, it's not a bad idea to sort of strategize and finding what will be the adequate interval and just kind of redo the trends once again so that they're all aligned on the same time period. I find it saves a lot of time for data treatment down the road.
Yeah, you're absolutely right. And some manufacturer or BAS manufacturer have better trending capacity depending on the type. Well, I think it got better and better with time, but the example of Delta was a good multi-trend capacity. So it's usually easier, I would say, in using these multi-trend capacity to have all the data aligned in the same graph. But you're absolutely right. Thank you, Jean-François.
Great. Are there other comments, ideas, bits of experience like Jean-François shared, or questions?
Been only a few days since we got back from vacation, so
True, my brain is barely warmed up.
I noticed in the chat there was a list of qualified commissioning providers. Is there a way to get on that?
Oh, I'm not hearing the question right. I'm not sure. Can you repeat the question? Sorry. Or maybe it wasn't a question. Not sure.
No, I was saying in the chat there is a list of qualified commissioning providers. I'm assuming that list was vetted by, I guess, you guys. Is there a way to get on that list or apply?
Yes, this question is more for the IESO representative.
Yeah, that's a great question. And there's a, if you, in the chat, Cynthia, who works with the incentive program, the EBCx incentive program, had a response to that. I think, and Cynthia, feel free to chime in on this, but the best step there, Alim, would be to reach out to that ebcx@ieso.ca email to ask about that, because that is a different team for the most part than we are here on the training and support side.
Well, someone posted an answer also in the chat, I guess. I don't know
Yes,
who.
that's Cynthia. Thanks.
Oh,
Thanks,
yeah.
Cynthia, for
Thank
doing
you,
that.
Cynthia.
Great question. Thank you. And just to follow up quickly, there was a question earlier, I think from Michael, about EWRB reporting and kind of the role of the qualified professional there. I just want to add, and you may be aware, but that the qualified professional requirement is only for year one, and then every 5 years after that, it's not an annual requirement. Okay, here we go from Irfan. Do light industrial facilities and open air retail facilities qualify for the EBCx program? Cynthia, this looks like another one for you. And then open air retail, would it be the aggregate minimum kilowatt hour requirements for the program?
Great question. I think if you guys can just email us, we can iron out the details offline.
It's just August.
Great. And that's the ebcx@ieso.ca email address. Is that right?
Yeah, that's correct.
Perfect. Thank you. I think there was a question above as well about, is the session recorded and will materials be available? Yes, the session is recorded. We're recording right now. And the recording and materials will all be shared on the Training and Support EBCx site, which there's a link to that site up near the top of the chat, but I will drop it in the chat again later on. And let's see, I think Jody's question is also a Cynthia question. I think we're talking here again about program requirements. And Jody asked, when submitting for the investigation phase, do we need to provide raw data or BAS trends to support that submission? Jody, are you asking about like the program, the EBCx incentive program application there? Okay, yes. Cynthia, do you want to respond to that one, or is that a good one to take up by email?
Yeah, I would say for sure follow up an email, but generally if you have trends to support any type of calculations, then we highly encourage you to include those.
Great.
And it will also be useful to convince the building owner or building manager to implement the change usually. So it's always good to have them.
Great. I'm going to drop just another couple of things in the chat. Oh, we had another question come in. Is being a CP, a certified professional, the same as being an approved commissioning provider? Insofar as we're talking about the being an approved provider for the Save on Energy incentive program, I think that, you know, is going to be best discussed by email. We also were talking about certified professionals for EWRB, right, which is a different context. And in some of the materials I shared from the province about EWRB, that there was a list there about the specific requirements for what they call being a certified professional. I'm just going to share here, make sure everybody has, this is the calendar for training and support events that are going to be coming up from Save on Energy. Right now, this calendar has everything through the end of February. Soon we'll have March links up as well. And that's where to go for events about EBCx, but also analyzing energy data, energy efficiency opportunities in commercial real estate, efficient electrification workshops, lots of different training and support activities going on that are available for folks. And then there was a question about the link to the NRCan pre-screening guide, and I can grab that real quick. Oh, thanks, Aurélie. Graham, that is a good question. I think Cynthia shared a link to the list of qualified EBCx providers for the incentive program. I don't know if that list is segmented by geography, but that would be a good place to start. A little further up in the chat here, I've got that link. I'll bring it back down. Here's that list of qualified providers for the incentive program. Great. If you do have a question or something you'd like to discuss with any of the presenters, feel free to hang on and share that question. For everybody else, really appreciate you sharing your time and attention with us this afternoon. Thanks a lot to Aurélie, Megan, Eddie, and the BPA team. And thank you, everyone. But if you do have a question, we'll hang on and answer it.
Thank you, everyone.
Thank you.
Thanks.
Thank you.
Have a great day.
Gael, your question about the portal, can you just provide a little bit more detail about your question? Or which portal you're asking about?
Hello, yes, it's about the EBCx portal. If I have like a campus with multiple buildings, and in the application phase, I have to add the square feet and the number of floors to the building. So I don't know if it's easier to put like the square feet of all the buildings, and I add the number of floor of the most highest building in the campus. What do you advise?
Right, in terms of taking a campus of buildings and presenting it as one versus individual buildings. I believe the program right now requires that you enter it as individual buildings, but that would be worth an email to the EBCx team at that email that Cynthia shared, which is just ebcx@ieso.ca. I think the standard answer is do it individually, but there may be exceptions there. It's probably worth checking.
Because some of the buildings are the square feet of the buildings are less than the minimum required to apply. So this is why I didn't went with the option of submitting every building separately.
Yeah, I know that there have been kind of other campus and portfolios that have run into that issue. So I would suggest you just contact them. Here, I'll put the email in one more time. So if you reach out to that email, you'll get the EBCx program team,
Okay.
and they can like talk to you specifically about your situation in your buildings and how to take that forward.
Perfect. Thank you.
Thanks for the question. Just going to do a really quick check, see if we missed anybody. If I missed your question or if you just haven't asked it yet, feel free to jump in.
Hi, yeah, this is Carlos from Stantec. I have a question here. Can you share any information with the nationwide program incentive for existing building commissioning?
You mean
If any.
outside of Ontario?
Yeah, if there's anything like that.
Oh, good question. I'm not aware. What are you? I don't know of any programs that are available across Canada, but in other jurisdictions, like other utility programs have their own. Is there a specific area or jurisdiction that you're interested in?
Yeah, like again, like I work in Atlantic Canada, and I haven't seen yet anything like that. I've heard about the Ontario, and I think it's a new incentive, but I was just curious if there's something on the federal level, like brewing up.
I'm gonna do a really quick check. If anyone else is aware of something at the federal level and knows more than me, feel free to jump in and answer.
Yeah, I'm still here, and to answer that, not to my knowledge, doesn't exist for the federal level. Here in Quebec, there are financial incentives from Hydro-Quebec and Énergir, but not from the federal.
There is so the program is called Building Optimization in Nova Scotia, but it really is a recommissioning or existing building commissioning program. So in Nova Scotia, there is an incentive program. I don't think there is in New Brunswick. Yeah, I don't believe so in New Brunswick, but there is that program available in Nova Scotia.
Perfect. Thank you.
Great. Well, thank you, everyone. Appreciate you hanging on till the bitter end, sharing all your time with us this afternoon. You can definitely, if you have other questions, EBCx related or otherwise about energy efficiency, if you reach out to us at training and support at iaso.ca. We love getting questions. We love answering questions. We've got a bunch of different folks, the BPA team when it comes to recommissioning, but also technical experts for all sorts of other facilities and energy efficiency opportunities. So please do reach out to us with your questions. Check on our upcoming events calendar, see if there's anything else you're interested in. And thanks again. Appreciate you sharing your time with us.